Hey guys, this is Chandler Vincent with weldermade.com, and I'm here to help you with some of the projects that we have going in our aluminum subscription. Check in the lower bottom corner of your blueprint to make sure that this is the same part numbers that you have on your blueprint to make sure we are referencing the same project. So we're going to start off by looking at the blueprint, kind of getting a good idea of the geometry, looking at all the different angles and views of the blueprint. But what's most important are these bubbles that tell you what part, and that gives that part a number so it's easy for you to reference. And then it tells you 1x, 2x, 3x, and that tells you that that part has, that there's 2 of those part, 3 of those part, or only 1. And that is going to help you a lot when we get into talking about parts 9 and 6. They are really close to the same dimensions, but they are different parts, and keeping your eye on these bubbles and referencing parts with numbers is going to help you out a lot in the long run. So first thing I'd always do is get all my parts unboxed and get them up here and start organizing and making sure I understand what parts are which. So we got these 2 parts that are 5 and 4 that cope together, and then we've got these 2 parts that are the same, and that has to be number 7. And then we've got these parts here where it gets really confusing, and I will show you up close, is these are parts 6 and 9, and they are only different by about 1/8 of an inch. These 2 pieces are part 6. They're 1/8 inch taller than part 9. They are the same width, but not the same height. So pay attention to that because it's going to be really important when we start tacking this thing up. So we've got 2 of number 6, and we've got 1 of number 9. We've got this big piece with the Welder Made logo in it. That is number 2. And then we've got number 3, which is the same dimensions, just with no logo. And we've got these 2 long parts that are parts 8. We've got 2 of those. And then we've got our base plate. And so a real cool trick when you guys are doing these kits is all of our parts are cut from the same direction. And if we have parts that are mirrored, we mirror them in our CAD drawings, and we make sure that it is all designed for the dross on the back side of the parts to go to the inside of the project. So if you're ever getting confused, just look on what side the dross is on, and that will help you reference where that part goes and the direction that it faces. Let's start cleaning these parts. I always use some sort of degreaser like acetone, parts cleaner. If it's parts cleaner, like brake cleaner, make sure it is non-chlorinated. If it's chlorinated, it can give off toxic chemicals and hurt you, and we don't want that. My favorite personally is acetone. A lot of people use a lot of different things. Just make sure that you are safe and wear the proper protective equipment when using these chemicals. Let's get cleaning. On the back side, you're going to have the dross that we need to clean. The best way I have found to do it is just with a flapper wheel and a die grinder. And the best thing I have found when cleaning it is you get this flapper wheel and you get this groove built into your flapper wheel. And that's where you can set it right on your plate, let your plate hit that groove, and that's what's going to give you those straight lines every single time. And that also makes it to where you're cleaning both surfaces at once. You're cleaning the weld surface and the surface with the dross at one swipe. And it looks good, it's professional, everything's straight. That's just a quick tip. That's the way I like to do it. There's a lot of other ways. You can just clean it with a file. You can hit it with a flapper wheel with a 4-inch grinder. There's a lot of different ways, but that's the way I prefer to do it. All right, so this is our Easy Tack tool. It is available on our website. I designed it to help you guys tack these projects up because, in my opinion, that is one of the hardest things to do with these projects. So I like to start with anything that is on the same plane and anything that is butted up together. So for example, on parts 8 and 7, those are on the same plane. They're a butt joint. We're going to tack those together on this flat surface here. Same with parts 4 and 5. Get my brand new clean welder's cap on that's never been used and get started. So on joints like this, make sure your draw sight is down and that you have the right part. And pieces that are mirrored, be careful. These can trick you multiple times. It's happened to me, it's happened to you, I'm sure. Just make sure that if you're tacking up this piece and you've got the other side mirrored. These pieces I tack without filler wire. Just because I know I'm going to add filler wire to it when I bring all the other pieces together. All right, there's those two pieces, and that is number 8 and 7. And now we are going to go to parts 4 and 3. We're going to get them coped together right in the middle. And make sure when you're tacking on sharp corners like this that you don't put a lot of amperage into your foot pedal or your torch to make sure you don't melt that corner off too far. All right, so now that all of those are tacked together, we can bring those pieces onto the easy tack as simple as this. Those rubber clamps do not scratch the material. They're easy to use, and it helps you line these things up perfectly without trying to tack them together at the same time. So if you all of these parts are laser cut perfectly. They're perfectly square, they're perfect dimensioned. So just take the time to make them right and make them all the same. So when you're practicing your welds, you're practicing on the same joint every time. That's going to give you the consistency to get faster, get better faster. And that's what we're here to do. And that's what our plan is. And so make sure you spend a lot of time on your fit up, because that's going to help you down the road. Just a little bit of filler wire on those corner joints to make sure that I do not melt away that edge too far. All right, now that's that piece. Now we're going to get parts 2 and 3. Tack them together using the easy tack. All right, we're going to rotate this over and tack plates 4 and 5 onto plates 2 and 3. And this is where it's super important not to melt that corner off too far, because then you don't have a place to reference these corner joints when you're tacking them up. And when you're using this easy tack, you don't have to have both corners perfect at the same time. So I like the way this corner looks, so I'm going to tack it, and then I'm going to worry about the fit up on that corner. Add just a dab of filler wire, and then we're good to adjust onto that corner. And we simply just take this, rotate it over, and we're good to go for the other side. And as you can see, really quick, we're starting to get this thing coming together really fast. And so now you also get to take this and keep using this tool that we've made for you and making your life super easy. There's not very many times you can't use this tool. The steel projects that we provide get a little heavy on there, but we just bump up to a little bit heavier duty clamps. All right, we're just rotating it over to the opposite corner and starting again. And really quick, she's coming together just perfect. All right, that is that whole assembly right there. She's sitting nice and flat. Everything's good there. Now we're going to tack the assembly of your two number 6s and your number 9 together, and put them together and make sure that they are the right pieces. What I'm going to do is start with my two number 6s and tack them into a corner joint. All right, now that we have that, we're going to turn it over just 90 degrees and clamp it again. And we are ready to add part number 9. Simply rotate it over. Put one clamp to hold it. All right, there's that piece. And that is our two number 6s and our number 9. And so I am done using the easy tack for now, so I'm going to set it aside. And now we're going to tack our two number 6s and number 9 to our final assembly. And just like that, we are fitting up real nice. When I get to this point right here on these edges where I know I have weld metal from tacking, I like to take my flapper wheel and just knock those down a little bit, and that'll help our tacking. Find one corner you like, glue it right where she belongs. And I like to leave the base plate for last so I can reach my hand in here and push out joints that need to line up better. We've got kind of a deep corner, so I'm going to bring my tungsten out a little bit further to get to the bottom of it. Okay, that is the majority of our assembly. It's all sitting flat. Sometimes you'll get a knob sitting on the bottom where you tack these, and if that's the case, you just take it down with your flapper wheel on your 4-inch grinder. Okay, everything's good there. I'm going to check my blueprint, and it looks like we're going to be an inch away from the edge all the way around. And so a trick I like to do is use my calipers. Make sure you zero them. Go all the way out to an inch. Lock it in. And just take your edge. And that scribes the 1-inch mark on all 4 sides. Just like that. Our base plate is an 8x8. It's perfectly sparse, so it doesn't matter the rotation. You set your piece in on the corners. Make sure it all lines up. we're good to go. So make sure that everything is tacked in all corners, and what that does is it keeps parts from warping, and it also lets the heat in this project disperse evenly. So when you have a tack bringing multiple plates together, that allows heat to transfer through those tacks into other pieces. And so if you have all these pieces connected together on all four corners, that allows heat to disperse evenly in this project. And that is very important when it comes to welding this project, because there's a lot of weld inches on this project. And if you don't manage your heat, it's going to make it really hard for you in the long run. A lot of these projects are heat management. I'm going to teach you a lot about what to do with heat. And so, for example, this project right now, I just got done tacking it. It's at an even 70 degrees. That's pretty much room temperature. And so as we go, I'm going to show you how much heat, how hot this part gets over a series of times. So what we're going to do is decide what welds we weld first. If they're heat sensitive, we weld those first. If they're parts like the fillet welds that need a little bit more heat to soak in there nice, we're going to weld those last. So we're going to use the heat of this project to help us in welding this project. And so what you guys need to think of when you're welding this project is weld sequence. So we want to cover up all of our starts and stops and our tie-ins and all of those things. And so what the general rule of thumb is you start with your verticals. You start with all of your vertical pieces. So what we're going to do is we're going to weld all four of these vertical corner joints, and then we're going to come up here and we're going to weld all of these vertical corner joints, and that will be all of our vertical members. And then the beauty of it is we're going to start welding our horizontal members. And what we're going to do is, if all of these corners are welded in this flat piece, when we do this final weld across this corner, it's going to tie in all of those welds, and it's going to hide all of your stops and starts. And if you do it right, you should only have one stop and start in this whole project. And I want to challenge you guys in testing yourselves and making that happen, because what that does is it helps the overall appearance of the project, and it gives less of the ability for crater cracking, which is a very big thing in aluminum. If you only have one crater, you only have one chance to get a crater crack. If you leave 5 to 8 craters on this project, on a project in industry, the more craters you leave, the more likely you are to have crater cracks. So I want you to think about that kind of stuff when you weld these projects, because this is why I designed these projects, and this is why we are doing this, because we want to learn everything we can right here so we can kick butt out there in the industry. So my weld settings are roughly like 250 amps. My balance is at 75%. My frequency is at 125 hertz. I am using a 332 4043 filler wire. This is a 5052 series aluminum. You can use a 5356 alloyed filler wire, or you can use a 4043. Both are going to work just fine. Before I start welding, I'm going to go ahead and brush with a clean brush that has only been used on aluminum. All right, guys, this project is ready to weld. To get the most out of this experience, leave the base plate, which is part 1, flat on your table. And that's going to force you to weld in all of these different positions. If you flip it over and weld everything flat, you're going to get really good at welding flat. But you're not going to get really good at welding in the vertical and horizontal position. To get the best out of this, please leave this base plate flat and test yourself and push yourself to improve your skills. All right, we're ready to go. All right, I cannot wait to weld this thing. Real quick, I'm just gonna add that this project is now sitting at 66 degrees. There hasn't been any welding on it. That's basically room temperature. We're gonna put one weld on this. We're gonna put one weld on this and see how much that brought the overall project up in temperature. We're going to start with these 4 vertical welds, and then we're going to move to these 4 vertical corners. It always goes verticals to flat to horizontals to match that weld sequence. When you're welding corner joints, you don't want a whole lot of tungsten stick out. It helps with the gas flow. Here we go. Biggest key, always be comfortable. This weld here is a really long weld. And I want to make sure that I can travel from the very bottom all the way to the very top. And the general rule of thumb is you always want to be more comfortable towards the last half of your weld. Most guys screw up by getting super comfortable on the first half, and then by the time they're mentally strained and tired welding through the first half, they're getting more uncomfortable as they get more tired. And so what you want to do is get uncomfortable in the beginning while you're mentally strong and focused, and then as you get mentally strained and tired and your arms are tired and you're feeding wire like crazy, you want to be getting more comfortable, so it's helping you as you go. All right, now that we have welded those 4, I want to show you how hot this project is starting to get. And already we are from 70 degrees to 90, 95. And that's with only 4 out of the many welds completed. All right, here we go. So focus on the radius, focus on the shininess, and focus on the depth of fusion. All right, let's do some horizontals. I'm going to start on this corner and weld all the way around, and I'm going to make sure that I'm going the same direction every time to make it look like that weld bead is continuous. All right, now I'm going to immediately start my puddle on that corner and melt that crater from the previous weld. And when you're looking for a full radius, the most place where people lose their full radius is right on the end of the corner, because they didn't fill that corner with enough filler wire. And so when you put a tack on that corner before you start welding, that helps because it automatically gives you more weld metal. All right, we've got all those welded, and now we are going to weld this flat butt joint that we have here on the corner. And what I want to do is I want to start on this corner and work my way into here, and then tie it up into this corner piece, and there's my stop is going to be right in that corner, and then I can cover it with this fillet weld around here. Does that make sense? All right, there's that. Started on the corner nice, kept a nice straight bead. When you're welding butt joints, what we're looking for is a consistent bead width. We always reference it as bead width variation. You want your bead width to stay the same, and what that tells me or an inspector is that your filler wire was consistent, your speed was consistent, your travel speed and your work angle and everything stayed the same. It just shows consistency. And then you want to not have too much weld bead reinforcement on the crown of your bead. So you want it to sink down in there, get good fusion. With this thin a sheet metal, it definitely should be penetrating on the backside. The best way I like to know that I'm penetrating and getting full penetration is when I start my weld puddle, I'll add a little bit of filler wire, and when I watch it droop down, I know that that weld metal has sagged into that weld joint and I'm good to go. So now that one's welded, I'm going to weld these 2 fillet welds so I can cover up my stop and start with this bead around here. All right, now that we have that fillet weld in, we can now cover that start with the start of this bead and carry it around and then cover up the stop to that bead, and that prevents us from having a lot of stop and starts in this project. I'm also going to weld these vertical butt joints real quick. Before I do this corner joint, I actually forgot that those were there. I'll hurry and weld those there. It's not too late to do that. On a butt joint, you cannot have much stick out because the weld geometry is flat and your shielding gas can't stay with your weld metal as good, so you don't want as far of a stick out on your tungsten when it comes to butt joints, especially vertical butt joints. All right, now that those are in, we're going to do this horizontal corner that wraps all the way around this project, and we're going to start here, continue all in the same direction, and end here. All right, guys, we are almost done. I wanted to show you the difference between what your tie-ins should look like and what they shouldn't look like. So I left this weld bead completely open so I can show you what the difference is if your weld sequence isn't right. So right now, this weld bead has already been welded, and I still have this vertical. So if I could have done this vertical first and then hid the stop with this weld, but I left it open to show you the difference. All right, guys, we just got done welding this project. All we have left is this bottom fillet, and I want to explain a little bit of heat management here on this project. So right now, this project is sitting at about 130 or close to 140 degrees, depends on the part of the project. So if you are welding this project at 250 amps or 200 amps or whatever you're welding it at, and you are used to start welding it at the base material at 70 degrees, 200 amps with 70 degree base material is going to weld a lot colder than 200 amps at material that is at 150 to 200 degrees. So as you're progressing through these projects, you either let off the foot pedal a little bit to get you a little less amperage. If you're not using a foot pedal, which a lot of people don't, you just go to your machine and adjust. So I'd say after every 2 welds, go down 5 amps. Or you can just travel faster and add more filler wire to compensate for the heat variation. And so the reason why we weld the fillet weld on the bottom last is because it requires the most amount of heat for 2 reasons. One reason is that a fillet weld and its geometry naturally needs more heat than a corner joint to make a good weld. And that's why a lot of people struggle with fillet welds while welding aluminum TIG, is because they don't understand that it needs a little bit more amperage, or that you can have a little bit longer of a tungsten stick out. And the hidden secret to a lot of reasons why people struggle with a fillet weld in the flat position is that they have a nice thick workbench underneath that, sucking the heat out of it as fast as they can put it into it. So if you're welding a fillet weld on top of a surface, especially if you have like a heat sink plate that's aluminum, I've seen a lot of people have 2-inch thick aluminum heat sinks on their workbench, this weld joint is naturally going to need 50 more amps than this top corner joint. And so the reason why we welded that last is because we wanted the overall temperature of this project to be higher to help us soak in this bottom fillet weld. So now I'm going to start in one corner and travel the same direction all the way around the project to make sure my ripples in my weld is all going the same direction that I went up here, so it just looks really good cosmetically. I'm going to bring my tungsten stick out just a little bit more since we're doing fillet welds. long fillet welds like this is going to require a lot more wire feeding, and that is where things get really hard for people that don't feed their wire very good. And a lot of being a good aluminum TIG welder, or a TIG welder in general, is being able to consistently feed your wire. And so if you guys are at home on the couch, grab you a piece of filler wire from work. Doesn't have to be a long piece. Just sit there on the couch or at the kitchen table and sit there and practice feeding. Because if you can feed consistently, it's a lot easier to get these consistent ripples. It's a lot easier to travel faster, and it's a lot easier to get a good weld if your filler wire hand is keeping up with your torch hand. All right, now that you've started the first part of the fillet weld, to go ahead and start right on the corner and wrap that weld bead around that corner and keep that fillet weld size consistent and have a full radius all the way around that corner. To the Welder Made family that got here from the QR codes that you got in your subscription boxes, thank you so much for tuning in today. I hope I was able to teach you something. I can't wait to show you what I have for you next month. And let me know in the comments below if you guys have any extra questions. I'm super excited to interact with you guys and help everybody progress with their skills. So that's it for the month of February for the aluminum subscribers. See you next time.